Well, good afternoon, everyone. Thank you so much for being here 3 minutes early. I'm gonna put the timer up. We're gonna get started in about 3 minutes, but in the meantime, please introduce yourself. So we're gonna do that. Both Emily and I are gonna do that in a little bit, but we would love to know where you're tuning from and to know what is your role.
Julia, is it as cold? So I know you're in Chicago. I'm up in Minnesota. How cold has it been for you these past couple of days? Because it has been brutal here.
I do Celsius, so it's hard to tell you. It's been like -15 Celsius. I don't know how much is that in Fahrenheit. I think it's like -2 or -3 Fahrenheit.
Okay.
So I
So
think it's
so very cold. Fair enough.
it, yeah, it has been very cold. How about you in Minnesota? I know you told me the other day it was -35. That is
Yeah,
crazy.
the wind chill was like negative like 35 in the morning. And so my daughter actually had a cold day. So she didn't go to school because it was too cold. Not
Yeah.
too snowy, not too icy, just too cold to go outside. But I think it's going to finally start getting warmer. I looked at the weather here and it's going to be like in the 40s in Fahrenheit like next week. And that sounds fabulous to me right now.
I love that. I can't wait. It's going to be a little bit higher up here too. And thank you so much, everyone. I see more people joining. We're going to get started in about 2 minutes. In the meantime, please introduce yourselves in the chat. And there's a little pill that says host and panelist. Thank you to the ones that have already introduced themselves. If you can, just change that to everyone just to make sure that when we have discussions or if you ask questions in the webinar, everyone else can see that. That'll be great. But yes, it's been very cold. I feel like sometimes what happens is that there's like a full spring that comes in, like just a fake spring, just to give you a little break, and then there's snow again. So yeah,
Yeah,
I I just can't wait for the summer.
real summer. Yes. And I am going to, me and my family, we're going to Mexico next week. And this is how, whenever I vacation, like around this time of year, this is what always happens to me. I like leave on like the warmest week of that season. Like,
Oh,
like I don't leave like when it's negative 30. I leave like on the week where it's going to finally be like 45. And then when I come back, I know it'll be like cold again. But I do get to see some sun here pretty soon, and I'm really looking forward to that.
yes, low 30s is also very cold. I come from an island. I am not used to this at all, but I salute you, Emily, for being used to this type of cold. And I'm glad you're going to Mexico to escape. I mean, I would take Mexico over 40-degree weather anytime.
Any day, any day. And yeah, you were in the Dominican Republic the other week, and that looked, yeah, I want to bring that energy. I'm excited.
Yeah. Well, yeah, just visiting family and visiting my parents. And in about 10 seconds, we're going to get started. Thank you, Ashley, Pamela, Tiffany, and Jamie, for introducing yourselves. I'm excited to get started with the item analysis and prep for the MISA webinar. And before we do anything, we're actually going to introduce ourselves. So, Emily, would you like to start?
Yes, I will. Thank you again so much for attending the MISA item analysis webinar. My name is Emily Miller. My pronouns are she, her. And I was a high school chemistry teacher for 10 years. During that time, I taught in our alternative learning program. I taught regular, I taught honors. So I had the opportunity to teach a lot of different kids at a lot of different levels and try a lot of different strategies. When I was a teacher, I was an NGSS pioneer and advocate in my science department. I was also a PSL lead. So I got to lead a lot of data-driven dialogue and data chats, which is my fave. And now I get the lovely opportunity to partner with districts to help them implement InnerOrbit within their schools. And this might be controversial, maybe not, especially after Valentine's Day, but I prefer savory over sweet. I'm not anti-chocolate by any means, but I would order an appetizer before dessert like any day. Like just more cheese and carbs always.
Well, I don't really agree with that, but I'm glad that there's some people that will not eat as much dessert so the other people at the table can have more. And my name is Julia. I was a teacher and a tutor for elementary students in the Dominican Republic for a few years, but I've now been supporting teachers and districts with their NGSS implementation for these past 3 years. My job is to partner and provide guidance to schools and districts implementing assessments in their NGSS instruction. I work as a district engagement manager for all the East Coast. And I also think matcha is better than coffee. I know a lot of people like coffee. I'm not one of them. But if you haven't tried matcha, it really doesn't taste like grass. I know people say that. If you know how to make it, it tastes really good. So yeah, hot take.
Yeah, I don't agree that matcha is better than coffee, but you are right. Matcha does, when done properly, does not taste like grass. So that is good. So today, thank you again for joining us. Our objective for our webinar today is we are going to analyze some released test items from the MISA, and then we're going to dive into some resources and strategies to help practice and prepare for that MISA test. So we're going to be here for about 30 minutes today. And during that time, we're going to first look at a release test item example, and we're going to analyze it a little bit to see how it's aligned to the NGSS and the different dimensions. And then from there, we are going to talk about what sense making is. And we're going to practice that a little bit and talk about how we can incorporate phenomena through a unit, how we can scaffold back a grade level if we need to in order to meet our students where they're at. And then from there, how we can eventually scaffold them up to answer those three-dimensional sense-making rigorous questions. We're going to look at some InnerOrbit items to help us do that. And please, 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 while we're doing this webinar, if you have any questions, put them in the chat. We are more than happy to answer things as we're going along, so please feel free to do that if you need to. Let's get started. One thing we wanted to do really quick is we just wanted to talk to you guys about what InnerOrbit is, just in case you aren't familiar. So InnerOrbit is essentially 4 things. The first is phenomena. So we, much like the MISA, take our assessment items and tie them to some sort of novel phenomena or novel situation. We really want our students to be able to apply what they've learned to something new so they can actually demonstrate that mastery and that sense making. And so speaking of the questions, we are an assessment platform. We have over 10,000 different assessment items on our platform. And one thing that I think we do a really nice job with that Julia is going to talk more about later is we've written our items to slowly scaffold students up to be able to answer those rigorous 3-dimensional questions. So we kind of slowly layer in 1 dimension, 2 dimension, to eventually get to that 3-dimensional question. Another thing we are is data, which I love. So not only can you see how students do on the assessment items, but we actually break down our data by the 3 different dimensions within the NGSS. So you can see how students are doing specifically on SCPs, DCIs, and CCs, so you can better target your instruction. And then the last thing we are is professional learning. So we offer a lot of research and context-based professional development and professional learning resources, much like we're doing today. We like to go and travel to our teachers at different times and model different engaging classroom strategies. And we are always, always open to teacher feedback, so we can always continue to improve what we're delivering to all of you at the same time. If you were interested in learning a little bit more about InnerOrbit, Julia just dropped in the chat a link that you can use to actually book a meeting with her, and she would be more than happy to talk about how you could incorporate InnerOrbit into your classroom or school site as well. So now that you know a little bit about InnerOrbit, let's talk about what sense making is and how this relates back to the MISA. So I have right here a sample item from the MISA test. So in this one, students research indicated that corals are animals that consume a variety of other small organisms. Corals are able to reproduce both sexually and asexually. The corals use asexual reproduction to expand colonies and use sexual reproduction to form new colonies that can be far away from the parents. So this is talking about how different corals also can survive in different they prefer to exist in warm, shallow water, and how this could potentially then affect them moving forward. So we've got some Punnett squares. So if there's any bio teachers in here, this one's for you. And what I want y'all to think about when looking at this question or looking at this phenomena, is are students engaging in sense making? The actual prompt that students will be answering using this phenomena is use evidence to explain why corals use this method of reproduction to produce offspring to form new reef colonies. So students have to look at this phenomena, look at this problem, and then they have to write a constructed response using evidence to explain why corals would use this method of reproduction to produce offspring. So in order to answer that question, are students engaging in sense making? We would love for y'all to write in the chat your thoughts. So do you think students are engaging in sense making in order to answer this question? You could answer a simple yes, you could answer a simple no, bonus points if you want to explain why. And while you're answering this in the chat, if you could please, that little blue button above the chat, make sure it says to everyone so everyone can see your responses. So thank you for already getting some responses out there. I'll give you like 30 seconds to a minute or so to process if you need to and type in the chat what you think. Thank you so much for participating and responding in the chat. I'm seeing a lot of yeses, and I would totally agree. So they have to apply their knowledge and understanding that that increased genetic diversity is an advantage, just like Ashley mentioned here in the chat. And this is ultimately what the NGSS and what the MISA is trying to get students to do, is this sense making. So just to further clarify what we mean by that. So representation is another form of questioning that we can do for students, but this is simply asking students to communicate ideas that they've previously learned. This is nice for diagnostic and formative assessments because it is important to know what your students know before you teach them new things on top of that. But it's going to be insufficient evidence of proficiency. You're not going to truly know if students can apply their understanding to new situations if you're just asking them to recall information they've previously learned. Our goal here is this sense making. So we want students to explain why or how in order to make sense of some novel phenomena. We want to apply the sense making into these summative assessments, because this is really a chance for us to measure that level of proficiency and mastery that we're looking for, which is ultimately the goal of the MISA and the NGSS. So how can we actually get students to like do this sense making? Where does this come from? When you are looking at the different standards within the NGSS, or the different performance expectations within the NGSS, they're always going to have 3 dimensions to them. So the actual performance expectation is going to be this MSLS 3-2. So develop and use a model to describe why asexual reproduction results in offspring with identical genetic information, and sexual reproduction results in offspring with genetic variation. And then you'll see these 3 different boxes underneath. Each of these boxes connects to one of the primary dimensions of the NGSS. The first being the DCI, which is simply what do students know? So this is the content, this is the information. And then the science and engineering practices is like the skills and what students physically do with that knowledge and with that information. And then the cross-cutting concepts are these concepts that exist throughout all different content areas of science that unite them all. And it's a lens that students can look at a problem through. In this case, it would be cause and effect. So when we're thinking back to that initial prompt that we looked at, which was asking students to use evidence to explain why corals use this method of reproduction to produce offspring, notice how they had to pull from each one of these dimensions in order to fully answer that problem. They had that model that they had to look at before with the Punnett squares to be able to use the evidence to support their answer. They have to understand the different forms of reproduction with asexual and sexual reproduction and how that affects traits. And then they had to look at that cause and effect relationship. So understanding how their reproduction would affect the offspring from there. And this is what we want to try to get to. And this is what Julia is going to talk to you guys a little bit more about, how you can actually implement this into your classroom and what this could look like.
Well, thank you, Emily. And I know some of us have been implementing the NGSS for years now here in this webinar, but it's always important to give that little refresher in case some of us needed to. Now that we've gone over what sense making look like, we're going to review some strategies we could use for test prep across the school year so that our students get used to transferring that knowledge to novel phenomena, which at the end of the day is what they're going to have to do in that MISA test. Now, going back to our performance expectation, MSLS 3-2, just to recap, it is asking students to develop and use a model to describe why asexual reproduction results in offspring with identical genetic information and sexual reproduction results in offspring with genetic variation. Now, we've mentioned using phenomena in these assessments and how the phenomena has to be novel, but how can we give opportunities for students to make sense of phenomena throughout the entire unit? And what are the different types of experiences that we can give them to practice for those rigorous questions that they're going to see on the MISA? Let's look at how we would use phenomena specifically throughout this unit. And this is a roadmap for phenomena that we built. And in the very beginning, we could start with this phenomenon. All of these phenomena are in orbit. We would discuss, why do roses come in different colors? And since we're still in the beginning of the unit, we would consider a lower stakes discussion, like a whole class walkthrough, about how a gardener planted red and white roses on their farm, and years later, they were surprised to see a rose that they have never seen growing in their bushes before. And we would include discussion questions that target the cross-cutting concept and the SCPs for the whole class to answer together. Moving on to the middle of the unit, we could talk about how a squirrel sibling might not be similar to them. Maybe we could separate the class in groups at this point of the instruction to answer questions collaboratively in a printed and scaffolded group phenomena exploration. In this case, students would discuss how both of these squirrels are eastern gray squirrels, but they're different morphs, meaning that they have different variations of a particular gene that codes for fur color. And in this stage, students are answering rigorous questions to target the DCI, the cross-cutting concept, and the SCPs, but with scaffolding from the teacher and support from their group. And lastly, we could assess students by building a short online assessment to be administered individually, covering how do mushrooms multiply, and where we look here at how fungi reproduce depending on their age and the environment. And in this final part of the unit, students should be able to engage with rigorous sense-making questions from the get-go without any scaffolding, without any help from their teacher or their peers too. So we can still provide scaffolding if we need to, but removing those scaffolds is really important for building student independence and confidence towards these questions. And at this point, we have plenty of phenomena for this life science standards for middle school. But what if our students are not there yet and they're still struggling even with the whole class walkthrough and discussion? What we would do in this scenario is for us to go from the middle school life science performance expectation back to third grade. So from the on grade level standard to the prior grade level standard. In this case, we're going to third grade, where students have to analyze and interpret data to provide evidence that plants and animals have traits inherited from their parents, and the variation of these traits exists in a group of similar organisms. So at this point, instead of just diving into what we would do with middle school life science, if we don't know if students are still ready to engage in those rigorous tasks, then maybe we can go back a grade level always. Now, we can first discuss, again, we could have the same dynamic that we had in the previous slide with a roadmap for phenomena. In this case, we only chose two, but we could start discussing how tigers get their stripes. And this is all about how many characteristics of organisms are inherited from their parents and how different organisms vary in how they look and function because they have different inherited information. Then we could go over the reason why the same type of flower can look so different. And it's all about the fact that tulips can be crossed to create a mix of flowers with some similar and some different traits. And again, all of these phenomena are in orbit. We have from 4 to 6 phenomena usually per performance expectation. And I know a lot of us already use InnerOrbit, but if there's anyone that doesn't, now you know that we have about 4 to 6 phenomena per performance expectation on the site. So main takeaways when we're thinking about using phenomena for test prep and throughout a unit. So practice, the first thing is that practice makes perfect. So we should be using phenomena throughout all units, not only during test prep season. And using different phenomena provides more opportunities for students to model and practice transferring knowledge and sense making. And if students are struggling with the phenomena targeting their own grade level band, we can always lower the stakes with a prior grade level band phenomena to give also further sense making opportunities and identify possible gaps in knowledge or skills. And that pretty much sums it up about using phenomena throughout a unit. Now, moving on to the rigor of questions. So we already talked about including different phenomena, right? But how do we actually get students from that very basic DCI only performance to those big 3-dimensional questions that we expect to see on the MISA? Let's talk about that now. So at the end of the day, our goal is to get students to that rigorous performance where they can use their knowledge through the lens of the cross-cutting concept and using the SCP to explain why or how a phenomenon happens, as Emily explained in the beginning. And that's what true mastery looks like. And it's what students need to be prepared for these assessments. But we can't expect them to get there overnight. And that's where scaffolding comes in. How do we support building them up to this level. So first, we need to identify the invisible steps that we're asking students to take. And if we're expecting them to go from simple recall to applying knowledge across dimensions, we have to be intentional about breaking that journey into manageable steps. And second, we need to gather data at each step, not necessarily just at the end, because it helps us understand where students are struggling and we can adjust or support accordingly. And by focusing on these steps, we're not just preparing students for the assessment. That is important. We're helping them to develop critical thinking and reasoning skills that will serve them far beyond the classroom. And that's how we use scaffolding towards sense making. How do we bridge that gap? This is where the representation is in the 3 dimension. Let's look at this with an example. And this is all about this phenomena about a C-star reproduction. Is it reproducing? Is it repairing, or is it ripping apart? And it's all about how if C-stars get injured or are in danger, they undergo an asexual process called fragmentation. And this means that if they can split their body into 2 parts, with each part eventually growing into a new C-star. Our end goal is this question, right? So our friend Drew says that if the C-star fragments enough times, it will eventually produce offspring with a genetic combination that is different from the initial genetic combination. Now, students have to develop a model explaining if this reasoning is correct. And this one requires students to engage in 3-dimensional sense making by pulling multiple scientific concepts and skills. And first, we have the science and engineering practice, developing and using models. So they have to use this SAP by creating a model to demonstrate, or yes, develop a model to explain if the reasoning of our classmate is correct. They have to use the DCI, which is inheritance, both DCIs, inheritance and variation of traits. And then finally, they have to identify cause and effect. So they have to use all these 3 things together. And the way that we would bridge this gap, as we said, we can't expect them to jump straight from representation to sense making overnight. And that's where 2-dimensional questions come in. And these act as a bridge between simple recall and full sense making. Some 2-dimensional questions combine the DCIs and the cross-cutting concepts, asking students to explain why or how scientific knowledge applies through a specific lens. And others combine the DCIs and the SCPs, shifting from recall to application by having them engage with scientific practices instead of just memorizing facts. And by incorporating more 2-dimensional questions in our instruction, we're helping students build the skills they need to fully engage in sense making. So it's a stepping stone. We can think about this as a bridge, a stepping stone, a staircase that we're building up that makes this shift to mastery much more achievable. And now let's look at some examples. So we would start with the representation question, right? This is a great example of a core content DCI only question. This one plays, as we said, a crucial role in assessing whether students are ready to start making sense of something novel. So if students are not ready to answer these types of questions, there needs to be some type of remediation, some type of activity to make sure students have the content down before they actually start applying it to something else. So in this case, it's all about the DCI, inheritance, and the DCIs, the 2 DCIs, inheritance and variation of traits. And this question is assessing whether students understand that inheritance and variation of traits, and if they can explain the differences between generic variations in sexual and asexual reproduction. Now, moving on to our second type of question, we would combine the cross-cutting concept with the DCI. So again, this type of question bridges the gap between simple recall and full 3-dimensional sense making, ensuring that students can explain that sexual reproduction increases genetic variation in C-stars. In this case, again, they have to use cause and effect. They have to apply what they learned about variation of traits, and they have to know, yes, so which of the following processes increase in genetic variation in C-star? And we're intentionally leaving out the SCP here because we just want to know if students can combine the DCI and the cross-cutting concept together to spot if there are any issues with specifically the cross-cutting concept here. Then we do the same thing with the science and engineering practice. This is another example of a 2-dimensional question, deliberately combining the DCI and the science and engineering practice while living out the cross-cutting concept intentionally. And this is important because it's going to allow us to specifically assess how well students can apply their content knowledge. Again, the DCI, inheritance. In this case, it's actually growth and development of organisms to the scientific practice of developing and using models. And it helps us pinpoint whether students' difficulties come from struggles when applying the SCP specifically. And this type of question isolates the DCIs and SCPs for us to understand where the gaps are and adjust instruction accordingly. So if they were able to meet the performance but for other questions, if they were able to answer questions for the DCI only, check. If they were able to answer questions identifying cause and effect, check. But they struggled with this one, then what they may need is support in developing and using models. So by designing assessments this way, we can not only strategically scaffold students' thinking, but we can also gather useful data and define next steps. Now, full circle, looping it back to our three-dimensional questions. And this question is a true sense-making task because it requires students to engage with all three dimensions. And this is the type of questions that best prepare students for the MISA. Instead of just recalling facts, they will have to identify, in this case, which of the options should not be included in a model explaining C-star fragmentation. And by scaffolding student through representation, two-dimensional thinking, and finally three-dimensional sense-making, we ensure that they are truly developing the skills that they need, not just for assessment, but for problem solving, scientific problem solving. And this is where we want students to be. We want them to be able to answer these questions independently, without any scaffolding, without any help from the teachers, without any help from their peers. And by breaking down this journey into intentional steps, we can support every learner in getting into this level of thinking. Now, just to recap, these are the types of questions that we talked about today, and these are the types of questions that you can use to bridge that gap between just representation and then three-dimensional sense making. And all these questions are in InnerOrbit, so if you're already using InnerOrbit, good news. So we start with core content questions, then we move towards core and content and practice questions, DCIs and SCPs, then DCIs and cross-cutting concepts, and finally building up to those big three-dimensional sense-making questions, which will meet the level of rigor that students would see on an assessment like the Maryland Integrated Science Assessment, or MISA. And I just wanted to show you some sample data. This is one, in case you haven't seen this is one of our reports on InnerOrbit, and some sample data that you can gather to help make these informed instructional decisions that we've been talking about to support students after giving an assessment on InnerOrbit. So if you give multiple assessments on InnerOrbit, and this data probably either from a big benchmark or a few formative assessments that are smaller, yes, so you can see students here need some support with scale, proportion, and quantity. And you can always see on InnerOrbit what is the specific element of this cross-cutting concept, of this SCP or of this DCI that students are struggling the most, they need most support in, and what are the strategies that are working for those DCIs, SCPs, and cross-cutting concepts that students are scoring really highly on. Now, we've been here for 28 minutes, and we said we were going to let you go on 30. And just in time, I'm going to pass it over to Emily so she can wrap us up and talk about next steps.
Awesome. Thank you, Julia. That was super informative. All right. So thank you again for joining us today. It was super nice to see you all. And thank you again for participating in the discussion earlier as well. Julia is going to drop in the chat again a link if you would like to make a meeting with her in order to talk about how InnerOrbit could potentially look in your classrooms or in your school sites. So feel free to click that if you would like to do that. If you want to go ahead and follow us on social media, we've got our two different at InnerOrbit EDU and at InnerOrbit NGSS. Also, our YouTube channel is a great place to go to get some more information and resources. We post past webinars that we've done on there, as well as just little like helpful how-to videos and tips and tricks with the NGSS. So that would be a great place to go as well. And you can also email us at inquiries@innerorbit.com if you just have any other general questions. But again, it was lovely seeing all of you. Thank you again for joining us today, and stay warm out there. Spring is coming. It is coming in theory. Thank you all so much.